Hello everyone, welcome to Mathematics in my channel. In the previous video, we evaluated the Fourier series representation of natural log of gamma function. So in that video, we didn't evaluate the Fourier coefficient Bn, integral from 0 to 1 natural log of gamma of x sine of 2 pi n x. So in this video, we are going to solve this integral. Well, this is a little bit hard integral, so let's evaluate. Well, first I'm going to take our integral is equal to I, and then we can write integral from 0 to 1. Here we have sine of 2 pi nx, sine of 2 pi nx times then natural log of gamma of x. So we know the series representation of natural log of gamma of x is equal to minus gamma times x. Gamma we know Euler-Mascheroni constant, minus natural log of x plus infinite sum n is equal 1 to infinity x over n minus natural log of 1 plus x over n, and here we have dx. Okay, then we can split this integral into three different integrals. So we can write here integral from 0 to 1 minus gamma of x times sine of 2 pi nx. So minus gamma times x sine of 2 pi nx dx, then plus integral from 0 to 1 now minus natural log of x times minus natural log of x times sine of 2 pi nx dx, then here we have plus integral from 0 to 1 sum of n is equal 1 to infinity x over n minus natural log of 1 plus x over n times sine of 2 pi nx dx. Okay, now we have three integrals. So let's take this integral is equal to I1, and this integral I2, and this integral I3. Okay, let's evaluate I1. So we know I1 is equal to integral from 0 to 1 minus gamma times x times sine of 2 pi nx dx. Well, how to evaluate this integral? Okay, first minus gamma we know constant, so we can take outside of the integral sign. Integral from 0 to 1, here we have x times sine of 2 pi nx dx. Okay, now we can apply di method. So derivative integration, here x, derivative of x we know 1, then derivative x1, so here 0, so here plus minus, then here again plus. So here we have sine of 2 pi nx, then integration, so minus cosine of 2 pi nx over 2 pi n, here minus sine of minus sine of 2 pi nx over 2 pi n square. Okay, then we can write here, now we have minus gamma parenthesis minus x times cosine of 2 pi nx over 2 pi n plus sine of 2 pi nx over 2 pi n perfect square, limit from 0 to 1. Then we can apply limit. So here we have minus gamma, so if we apply lower bound and upper bound, we know this is equal to minus 1 over 2 pi n. So we have gamma over 2 pi n. Well, then we have I2. So we know I2 is equal to here minus sign, we know constant, so minus integral from 0 to 1 natural log of x times sine of 2 pi nx dx. So to evaluate this integral, now we can use IBP, integration by parts method. So we have I2 is equal to minus, now I am going to take natural log of x as a first function. So here we have natural log of x times, now integration of sine of 2 pi nx, we know minus cosine of 2 pi nx over 2 pi n from 0 to 1, from 0 to 1. Then here minus sign, so here parenthesis. Now we know here minus, but here we have minus sign, so plus integral from 0 to 1. Now cosine of 2 pi nx over 2 pi n times derivative of natural log of x, we know 1 over x, so here x dx. Okay, then here we can apply limit, lower limit and upper limit. So here minus 1 over 2 pi n, so minus 1 over 2 pi n. Now if we apply 1, natural log of 1 we know 0, then minus, here minus, so plus, so plus times, if we apply 0, here I am going to apply limit. So limit, when lower limit x approaches to 0, natural log of x times cosine of 2 pi nx. Then here minus, so minus 2 pi n constant, so 1 over 2 pi n, integral from 0 to 1, cosine of 2 pi nx over x dx. Okay, now here we have another integral. So I am going to take this integral is equal to j1. Okay, now we know j1 is equal to integral from 0 to 1 cosine of 2 pi nx over x dx. Now here we have 1, so I am going to take limit y approaches to 0, integral from, now here y, so it's not a problem, so y to 1 cosine of 2 pi nx over x dx. Now we can take a substitution. So I'm going to take t is equal to 2 pi nx, then differentiate dt is equal to 2 pi n dx. Now we can plug in here, so we can write limit y approaches to 0. Now limit we know, lower limit when x approaches to y, here 2 pi ny, so 2 pi ny to 2 pi n. Here we have cosine of t over t times 2 pi n times dx, you know, dt over 2 pi n. We know this 2 pi n get cancelled. Okay, then here limit y approaches to 0, integral from here 2 pi n y to 2 pi n, here cosine of t over t, so I am going to write cosine of t minus 1 over t. Now here we have additional minus 1 over t, so here plus 1 over t dt. Okay, then here we can write now integral from 0 to integral from 0 to 2 pi n cosine of t minus 1 over t dt, and for this part plus limit y approaches to 0 integral from 2 pi n y to 2 pi n 1 over t dt. Okay, now we know this is cosine integral function. So here ci of x cosine integral function is equal to gamma plus natural log of x plus integral from 0 to x cosine of t minus 1 over t dt. So here now we can write for this integral, we know we have ci of x, we know 2 pi n upper limit minus gamma minus natural log of x, we know 2 pi n. Then here we have limit y approaches to 0, we can write natural log of y. So now we have I2 is equal to, we know, minus 1 over 2 pi n times limit x approaches to 0 natural log of x times cosine of 2 pi nx minus 1 over 2 pi n times j1 we know ci of 2 pi n minus gamma minus natural log of 2 pi n minus natural log of 2 pi n, then again minus limit y approaches to 0 natural log of y. Now we know this part and this part get cancelled, so we have, I'm going to write here I2 is equal to minus so gamma, then minus plus natural log of 2 pi n minus cosine integral of 2 pi n over 2 pi n. Okay, now we evaluated, we solved I1 and I2. So still now we have to integrate I3. Okay, now we know our integral I is equal to I1 plus I2 plus I3. I1 and I2 we solved. I1 is equal to gamma over 2 pi n, and I2 is equal to gamma plus natural log of 2 pi n minus cosine integral of 2 pi n over 2 pi n. Okay, let's evaluate I3. We know I3 is equal to integral from 0 to 1 infinite sum, here k is equal 1 to infinity x over k minus natural log of 1 plus x over k times sine of 2 pi nx dx. Here I take k is equal 1 to infinity, but in the beginning I used here n is equal 1 to infinity, but here we have n, so we may be confused, therefore we can use here instead of n k. Okay, then here we know we can switch integral sign and sigma notation. So we have k is equal 1 to infinity integral from 0 to 1, here x over k minus natural log of 1 plus x over k times sine of 2 pi nx dx. Well, now we have a product of two functions, so we can apply di method. So I'm going to take here x over k minus natural log of 1 plus x over k, and here sine of 2 pi nx, here plus, then here minus, so here we have 1 over k minus derivative, 1 plus, 1 over 1 plus x over k, so k plus x over k times 1 over k. So here we have k plus x, then here integration, so minus cosine of 2 pi nx over 2 pi n. Okay, then we can write now here this is equal to sum, infinite sum, k is equal 1 to infinity. Now here we have minus, so minus x over k minus natural log of 1 plus x over k times cosine of 2 pi nx, cosine of 2 pi nx over 2 pi n from 0 to 1. Then here minus minus, so plus integral from 0 to 1 over k, derivative 1 over k minus 1 over k plus x times minus cosine of 2 pi nx over 2 pi n dx. Okay, then now we can split this integral. So here now we can, before it we can apply limit. So we have here k is equal 1 to infinity. If we apply limit, here we have minus 1 over 2 pi n times 1 over k minus natural log of 1 plus 1 over k. Here we have minus 1 over 2 pi n, so minus 1 over 2 pi n, integral from 0 to 1, cosine of 2 pi nx over k dx, then plus 1 over 2 pi n minus minus plus 1 over 2 pi n cosine of 2 pi nx over k plus x dx, limit 0 to 1. Here now we can write this is equal to here minus 1 over 2 pi n, we can write outside of the sigma notation, so 1 over 2 pi n, k is equal 1 to infinity, here 1 over k, natural log of 1 plus k over k, natural log of 1 plus k over k, then here 0, so here we have plus integral from 0 to 1 cosine of 2 pi nx over k plus x dx. Okay, then we know this is the definition of Euler's Mascheroni constant. So here we have minus 1 over 2 pi n gamma plus here we have k is equal 1 to infinity, integral from 0 to 1 cosine of 2 pi nx over k plus x dx. Okay, now I am going to take this integral, this part is equal to j2. So now we can write j2 is equal to, we know infinite sum, k is equal 1 to infinity, integral from 0 to 1 cosine of 2 pi nx, cosine of 2 pi nx over k plus x dx. Now we can take a substitution. So I am going to take t is equal to k plus x. So we know dt is equal to dx, so we can plug in here. We can write here infinite sum, k is equal 1 to infinity. Now limit, we know when x approaches to 0, here k lower limit and upper limit k plus 1, and here we have cosine of 2 pi n times x, we know t minus k, so t minus k over here k plus x, we know t times dt. Okay, then now we can write here this is equal to limit, sorry, sum of k is equal 1 to infinity. Here we have k to k plus 1. Now for nk positive integers, n and k positive integers, we know cosine of 2 pi nt minus 2 pi nk. We can write cosine of 2 pi nt over in the denominator we have t times dt. Okay, then what can we do? Okay, now the boundary we have k to k plus 1, so I am going to break the limit, so we can write k is equal 1 to infinity. Now here 0 to k plus 1 cosine of 2 pi nt over t dt, then minus 0 to k cosine of 2 pi nt over t dt. Well, then we can take another substitution. So I'm going to take 2 times pi nt, this angle 2 pi nt is equal to v. So we can write here infinite sum k is equal 1 to infinity. Now limit, we know lower limit when t approaches to 0, v also approaches to 0, t approaches to k plus 1, 2 pi n times k plus 1, so 2 pi n times k plus 1, and here we have cosine of v over v dv minus, and here we have same as 0 to 2 pi nk cosine of v over v here dv. Okay, then I'm going to write here 0, so I'm going to use limit. Now I'm going to take limit beta approaches to 0, infinite sum k is equal 1 to infinity. Here integral from beta to 2 pi n k plus 1 cosine of v over v dv minus here again beta to 2 pi nk cosine of v over v dv. Okay, now in j1 here this is we know j2 we use a technique by using cosine integral function in evaluating j2, so we can use same technique, so the same formula. Now here we have two integrals, so we can write now this is equal to infinite sum, here k is equal 1 to infinity. Now here ci cosine integral function of here we have 2 pi n k plus 1, then we know here also we have minus gamma minus limit beta approaches to 0 natural log of beta, by in this integral also we have gamma and limit beta approaches to 0 len beta, so we know other parts get cancelled, so here we have cosine integral of 2 pi n k. Okay, now we can easily evaluate this infinite sum. We know this is equal to minus cosine integral of 2 pi n. So we have now I3 we have I3 yes, I3 is equal to minus 1 over 2 pi n minus 1 over 2 pi n gamma plus so here minus, so minus cosine integral of 2 pi n. So if we simplify here we know ci of 2 pi n minus gamma over 2 pi n. Okay, then we know I is equal to I1 plus I2 plus I3. So I is equal to I1 we know gamma over 2 pi n, then I2 we know gamma plus natural log of 2 pi n minus ci of 2 pi n over 2 pi n. Then we know I3 is equal to plus ci of 2 pi n minus gamma over 2 pi n. So if we simplify, we know here gamma get cancelled, cosine integral function get cancelled. So we have here gamma plus natural log of 2 pi n over 2 pi n. Okay, this is the answer. If you like this type of videos, please subscribe this channel. And this is actually a little bit hard and a long process I have ever done. Thank you for watching.